So we'll be talking today about how to gain more visibility into your energy storage system. As mentioned, this is the third in a set of 3 tutorials. If anyone's missed the first or second tutorial, these are available for access on our website. A little bit more about me as a speaker. So as mentioned, I'm the CEO and CTO of Nuvation Energy. I'm a degreed electrical engineer from the University of Waterloo. Waterloo is kind of Silicon Valley in the Great White North. And I started Nuvation in 1997. And I have a lot of CEO duties, but I do like to get my hands onto systems. And so in the day job, I find opportunity to work on energy storage systems. And then fun fact about me, my hobbies are also energy storage systems. So this photo on the left there, that's one of our energy storage systems. This is the system that we did with Train in Santa Rosa, California. So this was a demand response system. It's a 2 megawatt 4C energy storage system, an example of the sort of energy storage system that Nuvation can do. We did a full custom container design here, and I had opportunity to participate in some of the commissioning of the system. And then the other type of energy storage system is the one done in our hobbies. And so as a fun bit about me, we build Mutant electric vehicles that we bring to Black Rock City. And this is TechnoGecko, which is a Mutant electric vehicle built off of Second Life Nissan Leaf modules that we got from Spears. It's a 80 kilowatt hour system. It's actually a series plug-in hybrid with an onboard 100-gallon propane tank that allow us to run the onboard propane generator and the fire effects that are on the vehicle. So a little bit about my background and the things that I do. This gives us an opportunity to test Nuvation's products under some unusual and harsh desert conditions. So that's fun introduction. Let's take a look at the agenda. So I'll start with a brief Nuvation overview. If there's people who haven't yet had an opportunity to meet Nuvation, I'm going to walk through an energy storage system architecture and compare the traditional approach to energy storage architecture versus an independent approach. Got a few slides on what is a BMS, Nuvation being a battery management company. We perhaps have a wider scope of what we define a BMS to be. And then the core of our time is going to be spent on increasing energy storage system visibility. And then bonus topic that I included that wasn't on the original agenda is talking about ways to decrease energy storage system cost. So brief overview on Nuvation. So we have offices in Sunnyvale, California, as well as in Waterloo, Ontario, Canada. We started as an electric product design company in 1997. We've brought to market over 1,000 electronic products for our customers. We started our BMS product line in 2008. And if people who are in this industry can think back to 2008, back in those times when we talked about battery management systems and energy storage, people didn't really know what that was yet. And nowadays, energy storage is very much mainstream news. And you host webinars and 500 people show up. So all the cool kids are here now. Inside of Nuvation Energy, we do battery management system products. We have energy storage system engineering. We do energy management systems. And then as our roots are as an engineering company, we do custom versions of all of those things. Within our BMS products, our high voltage BMS goes to 1250 volts. This is our 4th generation BMS that we're now selling. We're working on our 5th generation BMS that goes to 1500 volts. And then our low voltage BMS goes up to 60 volts. And so this is sold into the telecom market, applications like forklifts and robots and things like that. Many of our sales are a combination of BMS products plus energy storage system engineering. So on the services side, we often do container specifications and selection. We'll be asked to evaluate different PCSs or make recommendations on which batteries are a good match for an application. Often we're doing custom site controller development in order to integrate the various equipment that's at a site. One of our services is designing for regulatory certification, and will actually manage an energy storage system through the certification process, such as UL 1973. We'll be asked to do thermal management calculations or create special data logging and analytics solutions. We have our own energy management system that we've developed. This is a behind-the-meter energy management system. So it does things like demand charge management and renewables integration. So we've got PV smoothing applications. We've done a lot of microgrid controllers and various other custom applications. It's a combination of the energy management system and the site controller. So the site controller is what does the hardware and system interface connectivity between the different parts of an energy storage subsystem. And I'll get into more of that. We're up over 130 installations worldwide. So certainly a lot of our installations are in US and Canada because that's where our offices are based. But then through our customers, we end up with systems all over the world. And so I think we've got every continent now except for Antarctica. And we ranges from systems that are hooked into the grid to systems that are on little tiny islands. And we're running the entire island. All right, so let's talk about energy storage architecture. And we're going to contrast a traditional architecture versus an independent architecture. So within an energy storage system, there are many hardware and software layers that are there. So, it starts with the batteries. On top of that is your battery management system. That will be communicated with usually by a site controller. The site controller pulls in your power conversion system, also known as the inverter, and is communicating with usually something like a container controller that it then pulls in information from your fire suppression system and your thermal management system. This then rolls up into an energy management system, which makes decisions on how energy is used. And this usually has a utility level SCADA system on top of that. So each of these increasing layers should intelligently condense and highlight information for higher levels. However, we believe that also full visibility of information should be available if desired. So kind of the traditional approach is a battery manufacturer who has also developed an in-house BMS. And this is kind of how the industry got started, because when the industry started, there were not yet available third-party BMSs from companies like Nuvation. And so this is kind of how the industry started. And I often draw the analogy to, when Henry Ford first built the Model T, that he had to do everything because there wasn't yet an automotive industry. However, today, the automotive industry has really specialized on specific areas. And so there's companies that make tires, companies that make engines, companies that make wiper blades. As the industry grew up, it made sense to have that specialization of expertise and domain knowledge. Energy storage has gone the same way. And so today there's most commonly an independent model where the BMS is selected independently of what battery you're using. A few different ways you can get to that point. One group of our customers is battery manufacturers that select Nuvation's BMS in order to manage their batteries. And they recognize our expertise is in electronics and software, and their expertise is in chemistry and manufacturing. Or another approach is a system integrator wants to choose the best BMS independently of choosing the battery. And so they get the best of both worlds inside of that. So this webinar is about discussing how an independent BMS architecture offers enhanced visibility, performance, safety, and cost savings over traditional architecture. So let's take a moment and define what is a BMS. As Nuvation is a battery management system company, we perhaps define a bit of a wider definition. So there's some people that believe that a BMS is really just there to protect the battery. And so it's to pay attention to things like voltage, temperature, and current. And if any of these things get outside of operating parameters, it's to open a contactor and keep the battery safe. That is part of a battery management system, but we would respectfully suggest that that's a bit like saying your brain is just there to keep us alive, and it's there to allow us to breathe and beat our heart. We would suggest that actually what makes us human is an intelligent brain that has a lot more capabilities. And this crosses over to an intelligent BMS. that the full scope of a battery management system does a whole lot more than just this left column of safety. So we're doing things like control, where we're doing balancing of cells, making current limits available to the power conversion system. We've got local analytics, where we're tracking state of charge, state of health, the available power capability and energy capacity. Then the BMS also operates for the entire system as the analytics gateway. And so this provides the ability to have data logging and event logging and provide all that information and networking to external controllers. This then rolls up to the cloud level, where we leverage the computing power and storage capability of the cloud. And this allows us to have advanced algorithms such as fault prediction and remaining service life. All right, so I'm going to briefly show Nuvation's independent BMS architecture. So as I refer to some terms during the presentation. So Nuvation has developed a configurable and modular architecture for our battery management system. What I mean by configurable is that the BMS works with virtually any battery chemistry and battery manufacturer. And this is really unique because most battery management systems that are out there are really fixed function. And so they're defined and certified for a specific battery with a specific chemistry with a specific stack voltage. Nuvation's BMS is recognized under UL 1973. And when we went through that process, we had to actually invent a new way to do certification because when we showed up at UL, they asked us, so what's the battery, what's the chemistry, what's the stack voltage? And we said, it's configurable. And so we actually had to invent a new process as to how you do functional safety on a configurable battery management system. Our BMS is optimized to minimize system integration time and effort. So for lab systems, we have customers that receive our BMS, wire it up, and have it operating in an afternoon. We are highly configurable, supporting on-the-fly battery performance optimization, and I'll show some examples of that. And we provide a really high data throughput. And so, all the parameters of the BMS are available at a 1 Hertz rate in order to feed into data analytics and predictive algorithms. We are continuously improving our product. We do a new software release about every 6 months, and that is available to have a BMS that continuously gets better. And then we're known in the industry for offering expert customer support from our engineers that are based in US and Canada. We thrive on customer feedback, and so our BMS product roadmap is very much driven by what customers are looking for and what they'd like to see in their next level of system. To show the different levels of our BMS, so it starts at the module level, and so this is our cell interface, and so it is measuring voltages, measuring temperatures, and doing balancing. That rolls up to our stack switchgear, which is the stack BMS. And so it's built around our stack controller, and it combines that with contactors, current shunt, fuses, manual disconnects, fan control, all the things you'd want on a stack level. And then for multi-stack systems, that rolls up into our battery control panel. And that's the system level BMS. And so it's built around our multi-stack controller and combines that with a wall-mounted unit with a touchscreen, networking, and UPS capability. And then for applications where customers look to Nuvation for energy management systems, we offer our end controller EMS. To look at this graphically, you can see the cell interfaces closest to the cells. They roll up in a daisy chain into the stack switchgear. The stack switchgear wired in parallel on the DC bus with communication done by the battery control panel. Inside of this, going back to this diagram of all the different levels inside of an energy storage system, Nuvation provides visibility from the EMS all the way down to each of the individual battery cells. So the EMS is really doing the software logic of how energy is used. The site controller is doing that hardware connectivity and system interfaces, and the BMS is then really our core technology. Nod, by the way, to KJ from Powen, who worked with me to put together these diagrams. They also have an independent approach on their BMS, and then they take that to the next level of an integrated approach of combining their BMS with their EMS. So let's talk about the heart of the presentation of increasing energy storage system visibility. So there's over a dozen different ways I'm going to talk about of how you can gain more visibility into your energy storage system. Grouped it into 5 major topics. So we'll start with talking about accountability through independent visibility. We'll talk about visibility that can occur before your energy storage system commissioning. So for example, visibility into fault prevention, and we'll give an example of Nuvation's SenseWare conductivity algorithm. It's an algorithm that allows you to look for issues with battery modules or energy storage system assembly. We'll talk about visibility into energy storage system operation, particularly corner cases that are best done with simulation. And we'll give an example of our BMS Cloud Simulator. We'll then talk about cloud to cell visibility during operation. And this starts with your BMS being remotely accessible and field upgradable. We'll talk about BMS Cloud Alerts and how this can push alerts to an operator. They can then log in and see any faults and warnings that are in the system, and there's a very fine granularity inside of that. Our BMS is highly tunable, and it provides for capabilities such as real-time modification for emergency response operation. We'll then talk about cell-to-cloud data logging, most commonly used for battery warranty tracking. And the last topic is visibility of energy storage system operating trends. So we'll talk about how visibility into detailed battery transparency. So for example, a per cell state of health algorithm that we use, and battery visibility with advanced algorithms, such as cloud computing to do remaining useful life prediction. So this first topic, accountability through visibility. So it is well established that independent third-party systems increase transparency and accountability inside of a system. We bring this up because we sometimes hear the point put forward that a BMS developed in-house by the battery manufacturers, quote unquote, the best BMS, because they're the ones that know the battery the best. Perhaps, but if we compare this analogy to a company, would it make sense for a company to say that you should use their in-house developed financial statements because they know their books the best? Actually, the way the industry works is we put greater credibility and faith on an independent third-party audit of financials, and that is considered safer for making investment decisions. So we would respectfully suggest that in selecting what battery manufacturer to use for an energy storage system, select one who has no concern about their battery being reviewed by an external third-party BMS. A lot of our customers are battery manufacturers, and they, with pride, use Nuvation's BMS because they know their battery will show well under this sort of visibility that we offer into their battery and variation between cells. So as a case study of the kind of independent BMS capability we can offer, I'm going to give an example where we detected a battery manufacturing flaw even ahead of commissioning. So this is inside of the topic of visibility into fault prevention. And can we use the data coming out of a battery management system in unique and advanced ways in order to detect anomalous behavior ahead of a fault occurring? So an example of that is we have an innovative algorithm called SenseWare conductivity. And so the BMS tests and rates the relative impedance drop of each of the sense lines, assigning a value to that between 0 and 1. And so we have on the right here, this is real data from one of our systems in the field. It's got a little over 5,000 cells, and we graphed here the SenseWare conductivity result versus the cell index. We then took this data and ran it into an unsupervised learning k-means clustering algorithm, and it came back with 3 distinct groupings of the cells. We then applied further analysis to that, and we graphed it versus the cell index in the module. And we found that cell 1, due to the manufacturing, has a higher SenseWare conductivity, basically a lower resistance, because that first cell is easier to access. The majority of cells show up in this blue group, but what was interesting is our algorithm also uncovered this group where there were 48 of these yellow cells that looked statistically different. So we went back to the battery manufacturer to ask what that was about, and we uncovered that there was actually a manufacturing defect in 48 of those cells, that there had been a change in the manufacturing process during our order. Battery manufacturer was great about it. They swooped in, took care of the system, replaced all those modules, and absorbed the cost on it. But the fascinating point here is our independent BMS provided a level of visibility into the energy storage system that we were able to detect and correct this problem ahead of system commissioning. If we hadn't done that, the system would have gone into commissioning, and then you would have had hotspots on these 48 cells that would have been subtle, but over time would have aged those cells faster than other cells in the system, and ultimately restricted the overall operation of the energy storage system and impacted cycle life. Another example of visibility into energy storage system operation is with simulation. So it's neither possible nor safe to test all the different corner conditions that we would want to have in integration of an EMS, a site controller, and a BMS in a physical energy storage system. If we had to do that, we'd actually have to take the physical system and cross over faults of voltage, temperature, current, and all the combinations of that. These situations can be instead software regression tested much faster, cheaper, and safer in simulation. So an example of that is Nuvation offers a independent BMS simulator. So this simulator runs the identical code that we have in our BMS product in the field. It's a cloud-based simulator. And so customers log into our simulator and they can use it to do things such as testing their energy controller. So they have a new energy controller. They want to make sure that all the protocol registers talk to each other. And then they want to run tests as to what that will look like in each of the different fault conditions. Our BMS is highly configurable with over 1,500 registers. And so if there's a change to the BMS configuration file, that could be run first in simulation before it's deployed to the field. We also offer model in the loop simulation of energy storage system designs. So people can actually take to the level of running financial models all the way against what the BMS reports in terms of available charge and discharge current limits. This little demo here is showing the interaction via command line interface. This can also be done using HTTP REST API. Let's now talk about cloud to cell visibility. So it really starts with remote access. And so this is taking detailed battery data and streaming it to the cloud. If a problem arises, a push alert from the BMS out to operators or technicians. That remote operator can then clear faults and perform updates. And for us, this all seems like table stakes. However, customers tell us that many proprietary or traditional BMSs are not field upgradable, or some of them are not even field internet accessible. So the system of BMS alerts can take warnings or faults or even just service orders within the system and generate push text messages and emails out to an operator or technician. They can then respond to that push notification, log into the system remotely authenticated, and they can evaluate the fault and in many cases clear that fault remotely. Inside of this, Nuvation's BMS provides a lot of granularity into warnings and faults inside the system. We keep track of over 50 of them. And so then when you log into the system, you can really see what's going on in the index of the fault. We also provide a BMS that can be remote upgradable, and we're told this is fairly unique. But you can log into the system and update the firmware that's running in the battery management system. We provide the visibility and access in order to do that. And this offers new features, such as continuously advancing algorithms in state of charge and state of health. We offer visibility into really fine tuning of the BMS operation. And we find we have to give a couple examples of tuning because most BMSs out there being fixed function, they don't provide this kind of visibility and flexibility. So for example, we can match the safe operating range of a power conversion system. So many systems, the operating range of the battery is actually a superset of the operating range of the PCS. However, if you get into a corner case where you're below the minimum operating voltage of the PCS, it's a difficult situation to recover from because you can't charge your battery. So it actually makes sense to configure the BMS to not allow the energy storage system to go below that level. And so now this is more than a battery management system. It's actually operating, managing the safe operating range of the entire system. Our state charge algorithms are very configurable because we find customers want different things out of it. Some customers want 0% state of charge to mean there's no energy, like there's no more electrons that can come out of this battery. Other customers, they want to, perhaps operate at an 80% depth of discharge. So they want it to report a 0% state of charge when there's actually 20% of energy left in that battery. And so they want 0% to mean the top of their reserve. We also offer the ability to tune current limits to control the loop response time, which can be really important when you're tracking to a specific power level. And many of these systems have a lot of DC noise. And so we offer filtering algorithms that can be tuned based on the system noise of a specific system. Within all of this, we're fundamentally an engineering company. And so we like to say we're the engineers that say yes. We're the engineers that make energy storage go. And so many of our engagements are a combination of a product sale, and then customers request customizations to our BMS software, which we're happy to do, and we have structures in place in order to support that. An example of the type of fine granularity of configuration we offer is in our stack connection sequencing. So inside of our battery control panel, you can actually select how you want to connect the different stacks inside of a system. So for example, if you wanted to connect in charge mode, the battery control panel would connect first the stack at the lowest stack voltage, calculate the available power, charge that up to the level of stack 2, and then within that configurable stack voltage threshold, connect that stack, have double the available charge power, and so on until all the stacks in a system are connected. Equally, you could connect it in discharge mode, and it would start with the highest stack voltage, or you can just connect highest capacity, and it will auto-connect stacks with the most similar state of charge. An important example I'd like to give in visibility is inside of emergency response. And so this is, when you have a problem, and is your BMS going to be there in order to give you the kind of visibility and flexibility that you want? This example is poignantly done. I remember at a conference talking with the CTO of Italy, and she gave an example where they had a frequency event and Italy dropped just below 60 hertz operation, and they were discharging from their energy storage systems in order to get back to 60 hertz. And they were using Samsung energy storage systems, and the systems hit a threshold and clicked off and actually shut down the Italy grid. And this CTO was really furious about it because she knew those energy storage systems still had 20% state of charge inside the batteries, but the system didn't give her access to it. She was like, this is ridiculous. I know it's going to breach my battery warranty in order to go below this threshold, but I have a country to run. So I don't care about my warranty. This is my asset. I own this energy storage system. I should be able to use it the way I want to use it. And so Nuvation's BMS exists in service to that. At the discretion of the customer, the BMS can be locked to battery warranty ranges, or it can be reconfigured real time without going offline to permit a emergency or deep depth discharge with a warranty cost to that. So to see what that looks like, I'll actually drag over a real-time system that we have operating. So this is what our operator interface looks like inside of a web browser. And I drained down this system so it got to its 0% state of charge. Let's say I wanted to modify the registers inside the system. I can actually click over here to my register map. And let's say I was about to trip a fault threshold of a low cell voltage fault. So I can actually go in here to this registers. I can edit what the threshold is. This is an LFP system, so it's currently set conservatively to 2.75 volts. But today, I want to be able to do a deeper depth of discharge. So I can actually modify this system to say, you know what, I know the cells won't be chemically damaged until I get down to 2 volts. So for today, I'm going to consume a bit more of my warranty, and I'm going to go all the way to 2 volts. That then upstates the system, and you can actually see now there's a wider warning range that I can go all the way down to 2 volts until I trip a cell fault. So that's an example of the type of real-time visibility and flexibility that Nuvation's BMS offers. So let's talk about cell-to-cloud data logging, most commonly known as battery warranty tracking. So there are 3 levels of battery warranty tracking. There's the stack level, the system level, and the cloud level, and we'll dive into each one of those. So at the stack level, this is done inside of our stack switchgear, and this provides visibility into tracking over and under cell voltage, over and under temperature, which of course is a function of whether you're charging or discharging, over current, over and under stack voltage, and then it's important to track energy throughput. So when you're talking about battery warranty, it's usually a function of, hey, this is a 15-year warranty based on daily cycling. Well, in the field, if the system is being cycled twice a day, then obviously that warranty is being consumed more quickly. And so it's important that the BMS track energy throughput. Within this, in non-volatile storage, at the stack switchgear level, we store all time maximums and minimums for the lifetime of the system, along with the index of the cell that's related to that. And we actually have an accumulated counter, kind of an odometer, if you will, that counts the accumulated time past a warranty threshold. So for example, it's a different thing if you are over voltage for 100 milliseconds or if you're over voltage for hours. That is a different handling inside of warranty tracking. This then rolls up to the system level. And so we have local data logging at the energy storage system site level inside of our battery control panel. This in the short term provides full capture of 1 Hertz data, and then it's decimated for longer term storage. This is resistant to power outages because the BCP is UPS backed. It's also resistant to network issues because the BCP has a cellular link inside of that should your local network fail. This then can be used to send BMS alerts of texts and emails for any warranty events. This then rolls up to the cloud level where we have Nuvation Energy Cloud Services, and we're now leveraging the power of the cloud computation, storage, and communication. So we can now store full 1 Hertz data persistently for the entire life of an energy storage system. We can then mine that data and do really interesting things in advanced battery analytics. So for example, we can do remaining useful life calculations, we can do fault prediction, we can actually do preventative maintenance tracking, such as things like cell replacement. I'll give an example of that. We can also see subtleties in the data to highlight soft issues and correct them ahead of system damage. So we had an example of this where we saw a slight temperature difference in an energy storage system in the field. We tracked it down to that it was the first and last cell in each stack. We actually investigated that further, and it showed that there was actually a wiring error, that the gauge of the wire used in the energy storage system was insufficient at the top and bottom of the stack. We were able to correct that. The customer went in and make the change, and that then provides the ability for that energy storage system to last longer because it doesn't have those hot spots. We can also highlight with big data slight differences in cell impedance to give visibility into cell aging differences. And I'll give an example of that. And we can show slight differences in balancing times that can actually give visibility into variations in cell-to-cell coulombic efficiency. So to those examples, let's take a look at how we can offer visibility into energy storage system operating trends. So we provide really detailed battery transparency. An example of that is per cell impedance. And so this is our high voltage stack that we use for testing in our lab. So it's got thousands of cycles on it. And we generated a histogram of the individual cell resistances. And we can notice that there's a few cells that are outside of the normal distribution curve. And so it raises the question, are these cells that perhaps need to be replaced? The answer to that is found by graphing it against a normal distribution. And we can see that these cells fall outside the 99% confidence interval. They're considered outliers and they're targets for replacement. What's fascinating is we can do this level of visibility ahead of those cells becoming really an issue in the system. It can then be scheduled as a regular service in order to replace those cells ahead of those infringing and restricting the overall operation of the energy storage system. Another example is that we can do state of health calculations and use that to predict remaining useful life. So the state of health is kind of the current health of the battery, and it's based on capacity and resistance. But we can actually develop algorithms that would actually predict the remaining useful life against a state of health threshold. So you have to say, you know, at this energy or at this cell impedance, we're calling that the threshold, at the end of useful life. This can be done in modeling, but it's actually really complicated. And so this can actually be better done with data-driven models. So what that looks like is you learn the typical degradation curves based on past operating conditions. And the more and more data that you can use inside of an algorithm like this, the more accurate it'll be. And then once you've trained up an algorithm, you can actually have at any given point a prediction of your remaining useful life. So we're working on algorithms like this right now inside of Nuvation's labs. Typically, this is done in the cloud so that you can get access of training a neural network. You train it over multiple systems, and they can use it for predictive use. All right, so now we go to our bonus topic. So this is a little bit outside of visibility, but I wanted to take a few minutes and talk about ways that an independent BMS can decrease energy storage system cost. Many people are interested in decreasing cost. So these are the points I'm going to talk about, that we can remove the cost of switching between battery manufacturers. We can remove the cost of integrating and managing multiple batteries in a single site. That also makes augmentation a whole lot simpler. We can offer flexible, heterogeneous energy storage systems, and we make BMS inventory management much easier. So in a typical system, each battery has its own BMS. This is kind of the traditional architecture. And what we hear from customers is that then from their energy management system, they have to integrate each time with each of these different battery management systems. And this is a integration process that is measured in months or even quarters. It's fairly involved. However, if you use Nuvation's BMS, we can then manage and abstract all the different battery types, and you only have to do that software integration once. So this is a huge savings in sort of system cost because you get that flexibility in order to use different battery suppliers and abstract the battery that's underneath it. Nuvation is effectively the device driver for all these different battery manufacturers and chemistries. This can also be useful in really large sites. So now we're talking about, you know, single sites that are measured in gigawatt hours. So for a site of that size, you know, sometimes it's not all one particular battery manufacturer. Sometimes you're going to have a mix of different battery manufacturers. So if you go that direction in a traditional system, then you're forever managing all these different battery management systems and any updates and maintenance around that. However, if you use a Nuvation BMS, you never have that problem. It's the same hardware interface and the same software interface across all these different battery manufacturers and even different chemistries. This also makes augmentation a whole lot simpler. So when you're thinking about how to design an energy storage system, you have to think about battery degradation. Either you over-design the energy storage system at the start, putting in extra batteries today in order to handle the battery degradation, or you augment the system later. From an economic perspective, it makes way more sense to augment the system later. Battery costs continue to come down and you can spend that capital later rather than now. However, this raises the bit of an issue of, is the specific battery and chemistry that I'm putting in today, am I still going to be able to buy that battery module from that battery manufacturer when I augment this system 5, 10, 15 years from now? However, using Nuvation's BMS, this problem is solved. We completely abstract the battery that is underneath it. And so it doesn't matter if it's a different module, a different manufacturer, or even different chemistry. The higher level software doesn't even need to know it's different. The battery management system manages that for you. As an example of what that can look like, we did a project with Centrica and NREL that combined together three completely different energy storage stacks into a single energy storage system. So this is done with string inverters, and we were challenged to design an energy storage system of three different power levels, three different energy sizes, all different chemistries, all different battery manufacturers, even different state of health. So we combined a power stack, an energy stack, and a second life stack. And typically you'd have, in the traditional model, three different battery management systems in order to manage and interface and integrate with. But with Nuvation's BMS, we abstract all that. And so we actually use the identical hardware for all three of these very different energy storage systems. And then for us, it's a fairly simple software configuration file in order to move between them. So this is the kind of thing that we can enable inside of unique energy storage design. And this gives you the capability to have a more cost-effective system, because then you can dial up and down the specific amount of power, energy, or second life inside of a system in order to optimize system cost. We can also improve cost through cost savings in managing BMS inventory. So what we hear from customers is when they're planning out large sites, they don't even know in advance, which battery manufacturer or even which chemistry they might use in future sites, but they know that these sites are in their sales pipeline and often committed deals, and they're still picking which battery manufacturer to work with. So with Nuvation's BMS, you can commit to using our BMS, commit to a volume order inside of that, get access to the better pricing inside of that without needing to commit in advance to which battery manufacturer we're working with, because again, we completely abstract that. So this is another way in order to save cost inside of an energy storage system by using an independent BMS. So with that, that completes our third webinar inside of this 3 webinar series.